Hello everyone, welcome back to the channel. So before we start, just one quick thing. This is going to be very basic, right? Like really basic. And honestly, this is the most important part which is there in system design and this is you need to understand from the basic flow itself. So once this clicks, everything else in system design, becomes very way easier. So like I would be not throwing you big terms. Let's actually draw what happens when you click a button because we all use apps every day, right? But we almost never think about what's happening behind the scenes. We just click, expect things to work, and that's it. But other backend things, we don't even care about it. But today we'll be looking onto it. Let's get started. So let's get started with our first question. What actually happens when you click a button? So you would be like, I clicked it, bro. Now you deal with it. So to deal with it, there are a lot of things in the backend which we need to see. So let's start with a basic thing. Users calls to API. So imagine this. You open an app, click something, be it login, send message or anything. That action becomes a request and that request cannot go anywhere randomly. So it first hits the API. Think of API like a gateway. Everything enters through it. Nothing directly talks to backend without it. And honestly, that's a good thing. Because direct database access, yeah, that's how system breaks. Or worse, how you break production on your first week. Then, now once the request enters, the first question is very simple. Who you are. So for that we have our authentication system in place, which decides is the user authenticated or not. The system needs to verify your identity, right? Are you allowed to do this or not? So every request carries something, a token, a session, something that proves it's you. Because without this, it's not a system anymore. It's just an open kiosk, like a free Wi-Fi but for hackers, not for you. Now, even if the user is valid, right? The request itself might be garbage. Anything. Missing fields, wrong format, unexpected values happens all the time. Honestly, user input is scary, and more than that, quality assurance or QA input are more even scary. They even break the system for this. So the system checks, does this request even make sense in a validation part? If not, it stops right here. It does not go forward. It will break the loop and stop the system at the right place, not moving forward. Because sending bad data deeper is like forwarding a bug to future you, and future you is not going to be happy with it. Then, now if everything looks good, the request is finally reaches the service part. This is where the real work happens, the brain of the system. Be it login, check password, message, store it, anything else, process it. Basically, this is where all your actual coding effort lives and also where most of the bugs are born. And then finally, data goes into the database. Now, if you look at this flow, it feels simple, clean, right? And honestly, for small apps, this is enough. But the moment traffic increases, this starts breaking. And that's when things get interesting. You introduce a caching layer with your service. Now this, imagine thousands of users asking for same data again and again. Every request it hits the database, things get slowed down very fast. So instead we use cache. Cache is like a shortcut memory. System checks, have I already seen this? If yes, return instantly. If not, then go to the database and check. That's why app feels fast. They are not doing full work every time. But yeah, same problem. Cache is great until it's wrong. Then you are like, bro, this is not what I asked for. Because debugging cache issues is different level of pain altogether. So moving further, we have another layer called queue. So if I add this part of layer into a system, so this connects with a service. Now what happens in this? Now think about heavy work, sending emails, processing files, reports, or anything. If user waits for all this, it's a bad experience. Like nobody wants to stare at a loading spinner forever. So system does something smarter. It responds fast and pushes that heavy work to a queue. So basically this is the fast response using a queue. So system pushes the heavy workload to a queue, right? Queue basically means I got your request, I'll handle it soon. Or simply भाई तू आजा मैं देख लूँगा. Then background workers process it further. So for the user everything feels instant. But behind the scenes the work is still going on. Further forward into our topic, we have a concept of microservices. We have a previous video as well on it where I have talked about why most of the microservices end up failing. So this is a microservices. So let's suppose this is service A, service B, service C all talks to the database. So service A, we have service B, and then service B is connected to the database system. Now, in real systems, it's not just one service, right? It is multiple services, each doing one specific job, be it users, handling users, doing payments, or sending notifications. All are separate. So now, request does not stop at one place; it travels, and this is where complexity begins. Because now you are not debugging one system; you are debugging conversations between systems, and failure if happens in any of that one service. Let's suppose service B is in failure. Now imagine one service failed, just one, right? But suddenly everything breaks because all everything is synchronous. Like group project. One guy disappears, whole team suffers, right? Logs start coming. Everyone says checking. And nobody actually knows what's wrong. And this is normal. This happens all the time. That's why systems are not designed to avoid failure. They are designed to handle failure. Now to step back and look at this in a whole picture. One simple click goes through all of these things. We check identity, we validate request, process logic, optimize with cache, handle async work with queues, split across different services, and all of this happens in milliseconds, which is honestly crazy. And this is where system design actually starts. Not tools, not fancy terms, just understanding the flow. Because once this is clear, you can build anything. And next time you click a button, just remember inside the full drama. See you in the next one. If you like the video, do subscribe. Thank you for watching this.